Hey guys, how are you? I want to share something to you about valve plate. So what is the purpose of the grooves, or sometimes the valve plate has a dumping holes from your outlet and inlet. So those dumping holes has a specific purpose. So I will explain and show it to you what's the purpose and how the piston chamber communicate with the dumping holes. All right, stay tuned. All right, so this valve plate here is open loop type pump. So we know that it's a pump because it has a bigger suction port or inlet, and then small outlets. Okay, so these two ports are the communicating area between the piston chamber. In the this hole here links to the pressure port, so that's linked. So if you see on the side, there's a hole there drilling. Okay, so if I light there, and then you see the hole, hang on, if you can see the hole, it has a light, so meaning that's common. So that's the drilling. Okay, so meaning those dumping holes, okay, those dumping holes link to the outlet. Okay, common to the outlet. Also here there's another dumping hole, number 3. This is linked to the case. Okay, it's not linked to the suction, because if you can see here, there's no drilling there, but linked to the case, this one here. All right, first, okay, so this area, these are the transition area. These are the transition area between the inlet to the outlet. Okay, this dumping hole here, the first one, is to fill or to supply the piston chamber, as the piston chamber go to the outlet. Okay, so as the piston chamber rotate from the inlet to the outlet, this hole here, the first one, is to supply the piston chamber fluid to avoid cavitation. Okay, next is as the piston is still drawing oil. Okay, now this second here, all right, let me focus. The second is to increase pressure in the piston chamber. So the purpose is to avoid the, or to prevent the flow reduction during when the piston chamber connect to the outlet. Okay, and also it will prevent pressure overshoot. Okay, so that's what happened here. The dumping hole number 3, which is linked to the case, is as the piston chamber decompress, it release the pressure and also the air if the piston chamber pressure is below saturation pressure. So meaning whatever air in the chamber of the piston or piston chamber, it will release to the case, and that air will release to the tank. Okay, so that when you go on the suction, there's no air. Okay, so because it will create aeration, All right. Now, the reason I draw this with a degrees so that I know how many piston chamber, okay, expose as it rotate. So let's say, so this is my barrel. I cut the barrel. There are 9 pistons, okay. I will put in there and rotate it. This is my center line, and then we'll see. This is the hole of the piston chamber where the oil go to the pressure outlet and also sucking oil from the inlet. All right. Okay. So now when we go to 0 degree, the piston chamber exposed to the pressure side is 1, 2, 3, 4, 5. Alright, so when you look at here, angle, number of piston. Okay, at 0 degree, 5 pistons exposed. 20 degree, 4. 30 degree, 4. 40 degree, 5. And then so on. So they always 5, 4, 5, 4, 5, 4. So if you have 5 on the outlet, you have 4 on the inlet. So same here. If you have 4 and 5 inlet, 4 outlet, 5 inlet, 5 outlet, 4 inlet. Okay? Alright. Now, I will show you the dumping holes. Okay? Here, so that's the first dumping hole, the second dumping hole, okay? When I turn back, let's say like that, see that suction out inlet port exposed? Okay. Now, that one still drawing oil. Now, if, see that first dumping hole, if the piston chamber is, to avoid cavitation, instead of drawing air, all right, let's say if that dumping hole is not there, when it is closed, see, and the piston in the piston chamber is still drawing oil, it draw nothing, so it will create a high vacuum. So it drawing air, okay? Instead, to prevent that dumping hole there, okay? They put, that's the purpose, to avoid cavitation. So to supply fluid. So here, see there, the transition between the suction and the dumping hole, they expose together. So meaning, as the piston chamber rotate, as the the barrel rotate, whatever insufficient oil in the piston chamber, it will supply. See, before that inlet port close. So it supply, and then when it comes to second dumping hole, which is there, okay? Alright, I need to, yeah, that one there is clear. So when it, see, that one, it pressurize your chamber, okay? It pressurize so that it avoid flow reduction. Of course, when you increase the pressure, it will increase the flow in the chamber, so that you avoid the flow reduction during discharge. So let's say you have a 130 cc per revolution. So, and then, you know, the displacement is times the area of the pistons, and then the length of stroke times the number of pistons. So in order to have a maintain constant flow, that's the dumping hole there, the second, that's the purpose, to pressurize, to increase the pressure in the chamber rapidly. And also, okay, when it comes to the, so 0 degree, so this one here, the piston now is on the top dead, going top dead, and then see here how much before it exposed to the outlet. There's still, let's say that's 0 degree and 10 degree is still not exposing at the outlet port. So if there's no damping hole there, because that damping hole is linked to the outlet, what happened? It will create a over pressure chute, okay? So it will overshoot the pressure, okay? Because still close. Imagine there's no damping hole there, and then your piston here is going to top dead, okay? So it's going up. Imagine if there's no hole there, there's a hammered, and then it will overshoot when exposed to outlet, okay? So that's why, so some design plate has a triangular groove, okay? Now the problem of triangular groove, okay, is there's no releasing of pressure and air from the outlet to the inlet. So that's the, see here at, let's move the camera, at 20 degree or even 15 degree exposed already in the outlet, on the outlet, and then see 10 degree, okay, exposed. Let's say that's 9 or 8 degree, it's not still closed. 10 degree open already, so between 9 open, then 20 degree exposed to the outlet, and then fully at this one, what degree is that? 40 degree. Now let's go to the inlet, the third damping hole, okay? Now this is the outlet port, so as we rotate, okay, so watch here, it exposed already there, okay? I'm gonna try to my light so that you can see it clearly. See the hole there? So this time here it decompress, okay? So when there's no hole there, it's pressurized these chambers, because remember this is from your outlet, so it still has a pressure there. Because see there, from the outlet close, and then it exposed to the damping hole number 3, which is released to the case. Whatever pressure remaining here, it will decrease, and whatever, if there's air there, okay, it will also release. So air release, because that's connected to the case, that hole, okay? Now imagine if that is a groove, a triangular groove connecting to the out inlet, then where did you release your air? None. So during suction, so there's air in the chamber because the piston is going down, is drawing oil. So the damping hole number 3, or this design, is very good because you can release your air and pressure. So sometimes there's a combination of damping hole and grooves or relieve grooves. So yep, that's the purpose, okay? So on the outlet, okay, imagine that one. This is your pressure here and then ripple, okay? Now this overshoot pressure is controlled by the damping hole, okay? If there's no damping hole, you have that overshoot pressure, okay? To avoid that, you need a damping hole so that you can prevent that. The ripple as well, so if that is the ripple is between this line, the center line is your load. Whatever difference, okay, from there to there, that is your pressure ripple. That's the percentage of the ripple. Okay, pressure overshoot, ripple, and noise reduction. That's the purpose of designing an optimal valve plate. The ripple, of course, it's normal because the piston are 4-5 4-5, you know. It's the communication is changing, so yeah.